What is mathematics? Is mathematics just numbers? In fact, yes, you will always need numbers in mathematics. But what's the fun in it? Mathematics can be a lot of things. For example, do you have any idea what a polynomial is? If no, you are in luck because you are here to teach a few of the topics of mathematics for you. So sit back and relax.
When we multiply, the given are the factors and we look for the product. 3 times quantity x plus y is equals to 3x plus 3y. And when we factor, the given is the product and we look for the factors.
Note: a polynomial is said to be factored completely only if each of its factors can no longer be further expressed as a product of two other polynomials of lower degree. Here are a few methods of factoring polynomial.
Number 1. Common monomial factor. Number 2. Common binomial factor. Number 3. Factors of difference of two squares. Number 4. Factors of perfect square trinomials. And last but not the least, number 5. Factors of quadratic trinomials.
Before we proceed, please take note that this video assumes that the audience are already well aware of finding the GCF and using the FOIL method in algebra. However, you can pause the video for a while if you want to recall the following.
Of course, we must not forget about common monomial factor. If each term of polynomial is divisible by the same monomial, this monomial is referred to as common monomial factor. For example, let's try factoring 153x squared minus 207x. Step 1 is to find the greatest common factor. The GCF of 153 and 207 is 9, and the GCF of x squared and x is x. All in all, the GCF is equal to 9x. Step 2 is to divide each term of polynomial by the GCF. 153x squared divided by 9x minus 207x divided by 9x is equal to quantity 17x minus 23. So the final answer is 9x and quantity 17x minus 23.
Let's now move to the common binomial factor. Here, if each term of a polynomial is divisible by the same binomial, this binomial is referred to as a common binomial factor. Let's try factoring a quantity x plus y minus bc quantity x plus y. Apply the same steps from the previous one. Step 1. The GCF is a quantity x plus y. Step 2. A quantity x plus y divided by x plus y minus bc quantity x plus y divided by x plus y is equal to a quantity a minus bc. Once you've done those two steps, you now have the final answer, which is quantity x plus y and quantity a minus bc.
Next, we have another method, which is factors of difference of two squares. The product of the sum and difference of two terms can be stated as quantity a plus b times quantity a minus b equals a squared minus b squared by doing the FOIL method. Since factoring is the reverse process of multiplication, the factors of the difference of two squares, a squared minus b squared, are quantity a plus b and quantity a minus b. For example, factor 4q to the power of 4 minus 25r to the power of 2. Step 1 is to find the first term, which is the square root of 4q to the power of 4. The square root of 4q to the power of 4 is 2q to the power of 2. Step 2 is to find the second term, which is the square root of 25r to the power of 2. The square root of 25r to the power of 2 is 5r. Step 3 is to get the sum and difference, and there you have the final answer, which is quantity 2q to the power of 2 plus 5r and quantity 2q to the power of 2 minus 5r.
Let's proceed to the next, which is factors of a perfect square trinomial. A perfect square trinomial is a trinomial that can be expressed as the square of a binomial. Let's have this example. First, we need to identify if the given polynomial is a perfect square trinomial. Step 1 is to check if the first and last term are perfect squares, then get its square roots. X squared is a perfect square and its square root is x. And 9 is also a perfect square and its square root is 3. Step 2 is to check if the middle term is equal to twice the product of the square roots of the first and last terms. 2 times x times 3. 2 times x is equal to 2x. Then 2x times 3 is equal to 6x. If steps 1 and 2 are all satisfied, then the given polynomial is a perfect square trinomial. Then proceed to factoring. Step 3. The factors of a perfect square trinomial follows the sign of the middle term. As you can see, the sign of the given middle term is positive, so the roots will take a positive sign. Step 4. Raise the binomial in step 3 to the second power. The final answer is quantity x plus 3 squared.
Lastly, we will have factors of quadratic trinomial of the form ax squared plus bx plus c. Ensure that the given polynomial is written in the standard form of ax squared plus bx plus c, where a, b, c are non-zero integral coefficients. There are two cases, which are 1. A is equal to 1 and 2. A is not equal to 1. Here are the steps in factoring. Step 1. Find all the factor pairs of the first term ax squared. Step 2. Find all the factor pairs of the last term c. And step 3. Identify the factor pair from step 2, whose sum is the same as the given coefficient b. Step 3 is a trial and error method. Once the right factors are identified, stop. For purposes of discussion, we will present all possible factors, but take note that you don't really need to list it all down, because it can actually be done mentally.
Example 1. X squared plus 7x plus 10. Step 1 is equal to quantity x and quantity x, since those are the only factors of x squared. We use positivity signs because both middle and last terms are positive. Step 2. Step 3. As you can see, plus 5 and plus 2 has its summary plus 7, same as the coefficient of the middle term. Therefore, the answer is quantity x plus 5 and quantity x plus 2.
Let's now have another example where it's not equal to 1 over 3x multiplied by 2 plus 14x minus 24. Step 1 is equal to quantity 3x times quantity x. We now use one positive and one negative sign since the last term is negative. Let us examine the factor pair negative 4 and positive 6. After cross multiplication, we have 3 times 6 equals 18 times negative 4 times x equals 4x. If you get the sum, the result is positive 14. Since 14x is exactly the middle term, our final answer is quantity 3x and negative 4 and quantity x plus 6.
That's all for the methods we will be teaching you. We hope that you now have a better understanding of the concept of factors of polynomials.
This is Gen 8 of Our Lady of Compassion 8. Peace out. Thank you for watching.